This is Matt's story. I'm going to be giving you an overview of the final project for our group, the classification and distribution of N and S-type asteroids. The background of this project was essentially looking at what types of asteroids in our solar system rich in metallic minerals are present, how large they are, where they're distributed, um, towards the ultimate end of trying to characterize these populations of mineral-rich asteroids for the purposes of mineral extraction, for specifically for rare earth metals that are becoming increasingly less common on Earth and are important in semiconductors and other applications that are important for technological progression. So overall, the body of asteroids that we examined was quite large. There were over 1 million rows in our data set, but less than 2,000 of them had been classified under any sort of taxonomic structure. So one of the biggest hurdles we had to face were classifying as many of the unclassified asteroids as possible. A lot of the data on spectral types was not present for most asteroids, and so we wanted to use machine learning in multiple different ways to try to classify these asteroids to ensure that we were getting the highest classification that we could with reasonable accuracy in order to try to characterize the general population and look at how the population of asteroids that were already classified compared to the ones that we identified. All three of our methods were able to sort the asteroids with 79% or higher accuracy in the training sets, and we deem this to be an acceptable level. Looking at the asteroids in question that were classified already, they were significantly larger than the unclassified asteroids, which would make sense as smaller asteroids are going to be more difficult to get robust data on that would allow for the classification of them by space bodies already. We did find similar distributions in a general sense, but there were some differences, and one of the notable ones was the diameter of the asteroids which were previously unidentified, which we identified as M-type asteroids, had a standard deviation that was even greater than the mean. We also found that M-type asteroids were present in various sizes throughout every cluster of asteroids in the solar system, which had very large implications on our original research question of where you might want to look towards for mineral extraction. Overall, we were able to identify some key differences between these populations, which are explained further in our summary, and back up the results that we postulated on to begin with. Thank you.